Okay, so in Unit 6 and 7, we're going to start looking at both exponents and radicals, and we're going to learn how to simplify them, combine them, do a lot with them. It's very important that you get a lot of these rules down because you're going to be applying them in Algebra 1, Geometry, and in Algebra 2. So let's start with the most basic rule that we've got for exponents. We've got 7 to the second, or 7 to the second power, or 7 raised to the second power. So what we've got here is the 7 is called the base, and then the 2 is called the exponent. What the exponent tells you to do is to multiply the base times itself this many times. So what this is telling you is that we're going to multiply the base 7 times itself one more time, so 7 times 7. So when we do that, we get 7 times 7 gives us 49. Now this entire thing right here, the base and the exponent together, this is called a power. Okay. Now the next type that we've got is 7 to the 0th. 7 to the 0th, or anything to the 0th power, is special. It's always going to be the answer 1 with the exception of 0. So if we have 0 to the 0th, that's going to be 0. So every time the answer is going to be 1 with this exception. Okay? So the one exception is going to be 0 to the 0th. Any other times that you see something to the 0th power, it's going to be 1. Then over here, 7 to the negative first. Whenever you see a negative exponent, what that's going to tell you to do is take the 7, which is in the numerator, and flip it into the denominator. Take the exponent with you. So if we have 7 to the negative first, what that's telling us to do is go 1 over 7, and then once we've flipped it, we're going to get rid of this negative exponent and just go 1 over 7 to the first. 7 to the first is just itself, so we get 1/7 would be our solution. Okay, so for problems number 1A and 1B, we're going to take what we just learned and apply it to these problems. So we've got 9 to the negative second. So once you see again that negative exponent that's telling you go ahead and flip that 9 down into the denominator. And we're going to carry with it the exponent, but we're going to change it to a positive because the negative has already done its job. So we get 1 over 9 squared, 1 over 9 squared, so 1 over 9 times 9 is 81. So our solution is going to be 1 over 81. For problem number 1B, we've got negative 3.6 to the 0th power. So remember that anything to the 0th power, with the exception of 0, is going to be 1, so the solution to that is 1. For problems 2A and 2B, we're going to try a couple more of these problems. We're going to be presented with a little bit more difficult of a situation though. So in this case, we've got 5a cubed b to the negative second. The one thing that you need to understand with exponents is that they're always going to be affecting only the things that they're attached to, or only the bases that they're attached to. So let's break this down. The 5 has an exponent of 1. The a has an exponent of 3, and the b has an exponent of negative 2. This negative 2 does not affect the 5 or the a. It only affects the base b. So that's the only thing that we're going to do anything with on that particular problem. So 5 and a cubed are going to remain exactly where they are, and there's nothing that we can do to simplify those. So we're just going to go ahead and rewrite those as 5a cubed. Now b to the negative second, that negative exponent is telling us to take the b and flip it down into the denominator. So that's exactly what we're going to do. We're going to go put b in the denominator, and remember that once it's flipped into the denominator, that negative has done its job, so it becomes a positive 2. So the solution is 5a cubed over b squared. There's nothing that we can do here to simplify this, so we're going to leave it as is. In problem number 2a, we're given y over x to the negative fifth. So what this negative is going to be telling us to do this time is to actually flip it up into the numerator. So depending on where your negative exponent is located, you're either going to flip it down or you're going to flip it up. So in this case, the x to the negative fifth is located in the denominator, so we're going to flip that into the numerator. When we do that, we don't have any more need for that 1, because what is 1 times x to the fifth? It's just x to the fifth. And that right there is the solution to that problem. In problem number 3, we're going to evaluate an expression for given variables. So we've got 3s cubed t to the negative second, and we're told that s is equal to 2 and t is equal to -3. So the very first thing we're going to do is we're going to just go ahead and substitute those values in for our variables. So we get 3, and then very important, go ahead and put anything that you're plugging into this equation or into this expression into parentheses, because that's going to be important for a little bit later on. So the s is going to become 2, and don't forget to tag on the cube. Then t is going to become -3, and then that's going to be raised to the -2nd. So there's a couple of different ways that you could do this. You could have actually started by taking this t to the -2nd and flipping it down and getting a new expression, which would have been 3s cubed over t squared, or you could wait and you could do it here. So what I'm going to do is just go ahead and take anything that needs to be moved and go ahead and move it at this point. So I'm going to rewrite this as 3 times 2 cubed over -3 squared. And you can see that because the 3 has an exponent of 1 and this 2 has an exponent of 3, there's nothing that I need to do with that. The -3 raised to the -2nd power, that needed to be moved or flipped down into the denominator. Now it's just a matter of doing order of operations. And since these are separated by a division bar, I can go ahead and work these out separately. So I get 3 times 2 cubed, which is 8, over -3 squared. -3 squared is 9. So then 3 times 8 is 24 over 9. And then that is going to reduce down to 8 over 3. So the solution to this is going to be 8 over 3. In problem number 4, we're going to use exponents to work on a word problem related to the growth of bacteria. So we're told that bacteria double in number for every hour. And so what we're given is the expression 1,000 times 2 to the h, and we're asked to evaluate for h equals 0 and h equals -3. So this h equals 0, that's telling us how many bacteria were there when the experiment started, because that's what we're going to call the 0 hour, or the 0th hour. Then if we're looking at -3, we're going to look at how many bacteria were there 3 hours before the experiment started. So let's go ahead and plug in 0 for h. So we get 1,000 times 2 to the 0th. Remember that 2 to the 0th is going to be 1, so you get 1,000 times 1, which is just 1,000. So when x equals 0, or when h equals 0, the value of, or the number of bacteria in the colony is going to be 1,000. Now if we go back and do -3, we're going to go 1,000 times 2 to the -3rd. And so 2 to the -3rd is going to give us 1 over 8. Or what we'll do is we'll go ahead and take that and we'll move that down into the denominator and get 1,000 over 2 to the 3rd. So this becomes 1,000 divided by 8, and 1,000 divided by 8 is 125. So there were 125 bacteria in the experiment, or in the petri dish, 3 hours before the experiment started.